Welcome to Networks Professionals.
Welcome to today's explainer. Look, if you are at all curious about the invisible, software-defined architecture that is literally powering modern cloud infrastructure right now, well, you're in exactly the right place. Today, we are completely unpacking the ONF Certified SDN Associate, or the OCSA for short. We're going to do a focused deep dive into what is honestly one of the few truly vendor-neutral certifications out there that focuses strictly on the absolute fundamentals of software-defined networking. We've got a lot of really fascinating ground to cover, and my goal here is to give you a crystal-clear, structured path to understanding exactly what this certification is all about, what it's going to demand of you, and ultimately whether it's the right move for your specific tech journey.
Okay, let's dive into this. Here is our 5-part roadmap for today's journey. 1. Demystifying software-defined networking. 2. The big tech connection. 3. Inside the OCSA exam. 4. Your 5-stage study roadmap. And finally, number 5, is OCSA right for you? Let's get right to it.
Section 1. Demystifying software-defined networking. So before we even touch the exam itself, we really need to establish the technology, right? The OCSA is backed by the Open Networking Foundation, which is exactly what makes it such a highly valuable vendor-neutral certification. It revolves entirely around software-defined networking, or SDN. Simply put, this is the modernization of programmable networks that totally separates the control plane from traditional hardware. Think about it like this. In the past, the network's brains, the control plane that decides exactly where the traffic goes, were physically locked inside the exact same clunky hardware boxes that actually moved the data. Well, SDN completely shatters that old model. It pulls those brains right out and centralizes them in software, which fundamentally alters how modern programmable networks actually operate.
And because of that separation, SDN isn't just some minor upgrade. It's a massive, industry-wide transformation. We're talking about the creation of entirely software-defined data centers. We're looking at telecom virtualization, where these massive telecommunications networks are suddenly running on agile code instead of rigid physical switches. It enables intent-based networking, and really, at its very core, it introduces true network programmability. You aren't just logging in and configuring a single router anymore. No way. You are actively programming the entire network fabric.
Moving on to Section 2, the big tech connection.
Now, what's really interesting about this slide is it answers the question, is this just some academic exercise or are companies actually using this stuff? The answer is a resounding absolute yes. Google Cloud, Amazon Web Services, Nokia, Ericsson, Cisco. These are the massive foundational pillars of the modern internet and mobile communication. And every single one of these major players uses SDN principles extensively in their cloud and telecom infrastructure. For any tech enthusiast or network professional out there, grasping these OCSA concepts is literally like getting the master key to modern digital infrastructure. The theories you learn here are the exact same mechanics keeping AWS and Google Cloud running at a global scale. It takes you from basic theory straight into practical reality, helping you understand exactly how cloud networking functions behind the scenes. It reveals how network automation is practically implemented to manage, thousands of devices simultaneously. You're going to learn how SDN controllers manage routing across vast distances. Ultimately, you're learning the future direction of the networking industry itself.
All right, Section 3, inside the OCSA exam.
When you sit down for this certification, you aren't just taking some standard run-of-the-mill test. You're being evaluated by the Open Networking Foundation, the very architects of the open networking movement and the open flow standards worldwide. So what are you actually up against? Well, the exam consists of exactly 40 questions. But hey, do not let that low number fool you for a second. These questions focus really heavily on network virtualization, controller functions, and deep SDN architecture, which means every single question carries a ton of weight.
And here's the kicker. You have exactly 60 minutes to complete the test. 40 questions, 60 tightly packed minutes. It is a fast-paced exam that requires you to know your material absolutely cold. There is zero time to second-guess the fundamentals here.
And this brilliantly illustrates the kind of depth we're talking about. You'll absolutely need to master core concepts, like the vital difference between proactive and reactive flows in open flow standards. But it certainly doesn't stop there. The exam really tests your depth on things like statistics and counters, availability, security, hybrid networking, and even some pretty complex migration strategies. You have to understand exactly how a secure channel operates within a modern SDN framework. Furthermore, you are going to be tested on a really expansive open-source ecosystem. You need to know how virtual switches, like Open vSwitch, interact with various controllers. Think ATOS, Open Daylight, Floodlight, and Rio. And you'll need to know how to do all of this while utilizing tools like Wireshark to monitor the traffic flowing between them. Just understanding how all these platforms fit together is a massive, massive advantage for your overall grasp of network programmability.
Section 4, your 5-stage study roadmap.
I want you to think of this roadmap kind of like leveling up in a video game. You don't just jump straight to the final boss, right? Assuming you already hold a foundational networking certification, like, say, a Cisco CCNA, here is your precise methodical timeframe. You're going to spend 2 weeks heavily focused on Linux basics. Then, you'll dedicate 4 solid weeks purely to studying SDN fundamentals. And finally, you'll spend another 4 weeks doing intensive hands-on practice. That is a methodical 10-week journey from traditional networking straight through to modern, software-defined mastery.
So let's walk through the actual steps. Your foundation is that core CCNA knowledge. From there, your 2-week sprint focuses heavily on essential Linux commands, SSH, and Bash basics. Once you're really comfortable there, you'll dive right into 4 weeks of studying SDN architecture, control plane separation, and OpenFlow resources. After that, you move right into 4 weeks of hands-on practice with Open vSwitch and Wireshark. This is where the magic happens. You'll actually create virtual networks, write flow rules, and execute controller-based routing yourself. And finally, step 5, you'll tackle exam practice questions, really zeroing in on the architecture and network virtualization topics that carry the absolute most weight on the test.
And that brings us to Section 5. Is OCSA right for you?
Okay, we've talked a lot about how incredibly powerful this technology is, but let's do a quick reality check here about actual industry demands. Because while SDN knowledge forms a phenomenal foundational understanding of modern networks, the reality is that employers frequently ask for broader networking or cloud credentials. The OCSA makes you undeniably smarter about how modern cloud infrastructure actually functions under the hood, for sure. But it's often viewed by hiring managers as a highly technical stepping stone rather than the final destination itself.
So, what does this all mean for you? I want to leave you with this final, provocative thought as you plan your strategic career trajectory. Are you going to take the time to deeply master the foundational mechanics of software-defined networking through the OCSA, so you truly understand how networks are built today? Or will you bypass those underlying mechanics to chase the broader cloud credentials that employers are actively demanding right now? There really is no wrong answer here, but honestly, understanding the difference is exactly what's going to set you apart. Thank you so much for joining me on this explainer, and keep learning.
Thanks for watching.